All right, IM3 classes. Moving on with our factoring, we're gonna do a bit of a review of factor trinomials. You may remember this from IM2. If not, that's okay. That's why we're going over it again. Starting out, just a reminder of what we mean by factoring. If we have a quantity, so say we have a number like 15, 15 factors into 3 times 5. All right. So we are going to be doing that with polynomials, specifically trinomials. All right. So we have a polynomial of 3 terms. We are going to factor this quantity, the whole quantity, into a smaller quantity that we would multiply together to equal this trinomial. So first thing we're going to do is use an X factor. Some people may remember these being called diamond problems. I like to call them X factor, just to remind us that we use them to factor. So on the top is a product. On the bottom is a sum. What you're going to do is you're going to take this last number, that's the product that goes on top. Then you're going to take the middle number, just the number, we don't need the A with it. That's going to go at the bottom. So to fill in the sides, what we want to do is come up with 2 numbers that multiply to get 4 and add to get 5. This one's pretty easy. It's going to be 1 and 4. So 1 times 4 is 4. 1 plus 4 is 5. If you need to fill this in, what you can do is just list out the pairs of numbers that multiply to get the top. So 4 is 1 times 4, and then 2 times 2, and see which ones add up to 5, right? So since this one adds, right? Easy with this one, don't really need to do that, but that's what you can do. So here, I'm going to show the whole step, and there's definitely a shortcut you'll see at the end. This 5 here, I'm going to split this 5a up into a 1a plus 4a. So this is going to get split up into 1a plus 4a. Bring down the rest, so there's a plus 4 over here, a squared plus, so yeah, again, all I do is you take this 5a and split it up into whatever numbers you have on the side here. And then we're going to do the factor by grouping that we did in yesterday's lesson. So I'm going to group the first 2 terms and the last 2 terms. And then on each group, I'm going to factor out the GCF. All right, so greatest common factor of a squared and a is a. Greatest common factor between 4a and 4, actually, I'm going to write down here. So I factor out an a. Then on the inside, I'm left with an a plus 1. Plus, here I'm going to factor out a 4. They have a 4 in common. Then you get a plus 1. If you forget how to do that, check out the video from yesterday's lesson about how to factor using GCF. And then I'm going to group the outside terms together. So the a plus 4, and then it's a plus 1 the blue. So as you can see, right, we have our 1 and our 4, our 4 and our 1 from up here. So there's a very obvious shortcut. We don't have to split all of this up, but it's going to be helpful for the next step. So if you, let's do another example, right? So, product on top, 18, negative 11 on bottom. So what are factors of 18 that add to negative 11? So the numbers that multiply get 18 would be 1 and 18, 2 and 9, 3 and 6. I believe that is it. Which one of these are going to add to 11? Well, 2 plus 9 is 11. So it's going to be a 2 and a 9, but it's a negative 11. So we need to make these negative. So it's going to be negative 2, negative 9. So negative 2 times negative 9 is positive 18. Negative 2 plus negative 9 is negative 11. So I'm going to take this negative 11 and split it up into a negative 2m minus plus plus a negative plus a negative 9m, and then bring down the rest. So plus 18 and m squared. I'm going to do my factor by grouping. So group the first two terms and last two terms here. I can factor out an m, so it'll be m times m minus 2. Over here, since this is a negative 9, I'm going to, the leading term, if it's negative, I'm going to factor out negative. So I can factor out a minus 9 here. And then I get an m minus 2. When I factor out a negative, it changes the sign on this one as well. Group the outside terms together, so it'll be m minus 9. And then the terms inside. So here's its factors. And again, very easy shortcut. You can use this, save yourself some time. Check out what happens when we get to its factors. All right. So let's do another one. Negative 63 on top. So if it's minus 63, it's negative 63. Negative 2 on bottom. So numbers that multiply to get 63. That'd be 1 and 63. 2 doesn't. 3 and 21. 4 doesn't go into it. 6 doesn't divide 63. 7. 7 and 9. And I think that might be it, but this is what we're going to hear. We're going to use our 7 and 9. Since it's negative, one of them has to be negative. So it's going to be a positive 7, negative 9 is going to be equal to a negative 2. So positive 7, negative 9. All right. So k squared. Again, I'm going to split up the negative 2k to I'm actually going to put the minus 7 or the minus 9 first. Minus 9k plus 7k. And then bring down that minus 63. Group the first two terms together, last two terms together. I can factor out a k here on the first one. So that's going to be k minus 9. I can factor out a 7 here. And then k minus 9. Then group the outside terms together. And then we have the k minus 9. Again, take a look at the pattern that's going on here. Positive 7, minus 9. All right, so let's do one more. And we're actually just going to do the full shortcut with this one. So product on top, so negative 10 on top, positive 3 on bottom. So numbers that multiply to get 10 are just going to be 1 and 10, and then 2 and 5. 2 and 5, I need one of them to be a negative. It's going to be a negative 2. Because negative 2 plus 5 is positive 3. So negative 2, positive 5. I'm just going to skip that whole middle step of factor by grouping. I'm going to write out my factors here. And the factors are each going to get an R. And then it's going to be minus 2 and then a positive 5. So that is it. So that's really all you need to do for those trinomials. The next set that we have a number out in front here. So this is going to be a little bit different. So when we start, I'm going to do my X factor over here. So first thing, the top isn't just going to be the last number. When you have a number in front of the square term, the n square, the first term, you got to multiply these two. So 2 times 35 is 70. And then this bottom, this number goes here. So that's the difference. Let's go back one. Nothing in front of the r squared or x squared or whatever the squared term is. You just put the last number here. If you really want to, you can pretend there's a 1 here. 1 times negative 10 is negative 10. So when in doubt, you can multiply. But here we have a number in front. We got to multiply it together. Middle number still goes in the middle. All right. 70 times 2. This is going to be 10 and 7. 10 times 7 is 70. 10 plus 7 is 17. All right, so here's the thing. We can't just use that shortcut that we used on the other ones. It's n plus 10 times n plus 7 is not going to be the right answer, right? Remember, we're undoing multiplication. if we were to multiply this back together, this 2 isn't going to be in there. So we got to take care of that too. All right. So this is where we do kind of need to do the factor by grouping. So I'm going to write this out. I'm going to do it over here. So it's going to be 2n squared. I'm going to split this 17n into a 10n plus 7n, and then plus 35. So again, this 17n is getting split. That's where those are coming from. All right. Factor by grouping, I'm going to group the first 2 terms together, last 2 terms together. Now, common factors here. The greatest common factor is the first one. I can take out a 2 and an n. So I'm going to have n plus 5. Plus, this one, greatest common factor between 7 and 35 is 7. Then I get n plus 5. Now, if I group the outside terms together, 2n plus 7, and then n plus 5. And there we go. Now, if I were to multiply these together, I got that too, right? So let's do another example. Right? So my x factor, now I have a 7. I mean, I got like the same numbers here. 7, now I got to multiply by a negative 10. That's going to be a negative 70. Then it's a negative 3 on bottom. It's going to be 10 and 7 this again, but it's going to be negative 10, positive 7. Should have picked a better example with different numbers, but that's okay. So first thing I'm going to do is, so I have the 7k squared minus, I'm going to change this minus 3k into a negative 10k plus 7k, so minus 10k plus 7k, and then minus 10. So again, this negative 3, that's negative 10 plus 7. I'm just splitting it up to negative 10 plus 7. All right, so group the first 2 terms together, last 2 terms together. There's no greatest common factor between 7 and 10, but between k squared and k, I can take out a k. I'd be left with 7k minus 10. Plus, there's no greatest common factor here. So I'm going to say I'm going to take out a 1. Then it's 7k minus 10. So group the outside terms together. So be k plus 1. And then these are stay there. So it's k plus 1 times 7k minus 10. All right. So there's a little bit of a shortcut to this. So let's do one more problem. I'll show you the shortcut. So if you don't want to do the factor by grouping, let's do the shortcut here. So it starts off the same way. You still have to use the x factor. I'm going to multiply the first and last numbers together. So 10 times 6 is 60, negative 19 on the bottom. Got to think about this one for a minute. So the pairs that multiply to get 60, so 1 and 60, that's not going to do it. 2 and 30, that's not going to do it. 3 and 20, we're getting closer. I'm not going to get 19 out of that. 4 and 15. 4 plus 15 is 19. It needs to be negative, so it's going to be negative 4 and negative 15. Here's where the shortcut comes in. All right. If I don't want to do all the factoring by grouping, what I need to do, since I multiplied to get by the 10 in front to get this top number, I need to divide that 10 back out. So I'm going to divide the sides by the first number. All right. And then I'm going to reduce the fractions. So negative 15 over 10, those each divide by 5. That's going to be negative 3 over 2. And then here, negative 4, I can reduce that. That's going to be a negative 2 over 5. All right. And then these is what I'm going to put into my factors. All right. So Each factor gets an A. All right. The numbers on the bottom, the numbers in the denominators are the coefficients on your variable. So they're going to go in front. So this one, the factor I'm going to get from this is going to be a 5A minus 2. Factor I'm going to get from this one is going to be a 2A minus 3. Right? And that is it. So if you don't want to divide everything out, and actually, let's go back one. And I'll do this method one more time so we can see. We'll do it again on this one. So erase all this. We did it with the factor by grouping. We'll do it again using what we just did. So here, multiply the first and last numbers together to get the top. This is negative, so that's going to be negative 70. Negative 3 on the bottom. Factor negative 70, that adds to negative 3. That's going to be a negative 10 and a positive 7. Since I multiplied by the first number to get the top, I have to divide that first number back out. So I'm going to divide the sides each by 7 and then reduce. 7 over 7 reduces to 1 over 1. Negative 10 over 7 does not reduce, so we leave it like that. And so now I can put this information into the parentheses here. So it's gonna, this one, in the factors, the parentheses, they each are gonna get a K. So it's going to be 7K minus 10. And then this one, it's 1K, since positives can be plus 1. You don't need the 1 there. So if you remember, our original answer is just 7K minus 10 times K plus 1. Don't need the 1 in front, but that's fine. And there we go. That is factoring trinomials. We'll have more factoring practice next time.